We are starting the class. We have here simple kinetic theory of matter. Anyone has microphone problem? Sound is coming from you. The sound coming from the ocean, like that. Are you in the longest beach of the world? From there you are attending the class. Okay, so heat capacity, specific heat capacity, all these things we discussed yesterday. We started melting point we discussed, right? Also we discussed condensation. And then solidification, this thing we discussed, right? Freezing. Now we'll recall whatever we discussed yesterday, then we'll go for new things. Okay, so we will say, Kaji Jawad, is your microphone working? Hello? Then Muhammad Saad. Hello, Muhammad Saad.
Yes, sir. Hello.
Yes.
Hello.
Tell us about yesterday's discussion. Melting point, freezing point, all these things. Please just recap.
Okay, sir. Melting point. When a solid changes to a liquid on heating is called melting point.
That is called melting.
Oh, melting. Sorry. And the melting point is, sir, when a pure substance melts at a definite temperature.
Okay, so melting is a process and melting point is a
melting
temperature.
Point is a temperature. Yeah.
Okay, melting is a process in
And
which
melting point
solid turns to liquid.
Liquid, yeah.
On heating, that means you have to give external heat. Okay, on heating at constant temperature, right? So
Yes,
in melting process we have constant temperature. That means I gave you example like ice turns to water. That time the ice temperature is 0 degrees Celsius, and until it turns to water the temperature remains 0 degrees Celsius. This is called constant temperature. Okay, so during the melting process the temperature remains constant, and melting point is the temperature at which a substance starts melting, right? That is called melting point. We gave here some examples. Melting point of ice, 0 degrees Celsius, wax, 57 degrees Celsius, tin, 232, gold, 106, 7 degrees Celsius. And what about freezing? Saad, what about freezing?
Yes, sir. Freezing is a process by which a liquid changes to a solid by cooling.
By cooling, okay.
Yeah.
So this one is the reverse process of melting, right?
Yes, sir.
And what about boiling?
Sir, boiling is a process by which a liquid turns to a gas or changes to a gas.
Yeah, liquid turns to gas, or liquid turns to vapor.
Oh yeah, vapor, water vapor, liquid vapor.
Yeah. So that one also at constant temperature, right?
Yes, sir.
And this boiling, we are getting the boiling point also, right? For boiling also we are getting boiling point. So
Yes, sir.
how can we define boiling point?
Sir, boiling point. Uh, sir, boiling point is a temperature, is a definite temperature at which is a liquid starts to boil.
Starts to boil. Very good. So point, when we are saying melting point or boiling point, it's related to temperature, right? And when we are saying melting, boiling, this is related to process, right?
Yes,
This
sir.
process is called melting or boiling, but the temperature is related to point. You remember this one. So they who were absent yesterday, uh, Aisha was absent, Nubrat, Rabi, Faiza. You were absent yesterday. I suggest all of you to go through the recording. Today, I hope I will upload the recording of yesterday also. Then you will understand what we discussed yesterday. Please go through. Yesterday we discussed in details melting, then melting point, freezing point. Uh, and if you go through the recording, I hope you will understand all those things. Now we have solidification and freezing is the same thing, right? We discussed yesterday. Hello, Saad, Jawad.
Hello, sir. Yes, sir. Hello.
Yesterday we discussed freezing. That one
Yes, sir.
and solidification, the same thing, huh? In
Yes,
some
sir.
places,
Same thing.
in some places you will get solidification, and some places you will get freezing.
Freezing. Yeah.
So solidification is also done. Here you see some of the things they are mentioning here. Effect of impurities on the freezing point of water. Yesterday we discussed a little bit, right? Salt water and normal water, they have different boiling point, right? Due to the impurity mix up, they have different, freezing point or boiling point. So can you read this part here? How impurity is affecting the freezing point? Can you read this?
Yeah. Yes, sir. Effect of impurities on the freezing point of water. During water during winter in cold countries, the expansion of water on the freezing can can co- in, on the freezing can cause pipes in car cooling system or home to burst. To prevent damage to the car cooling system, drivers add antifreezing to lower the freezing point of water.
Okay, wait till here. So why it happens? Do you know
No, sir.
that
Why?
why it burst? You know that
No, sir.
if we are getting ice from the water, the volume increases. One 1 kg ice and 1 kg water. If you take, then we will get the ice has more volume. Do you know this?
No, sir.
And did you see any place that ice is floating on water?
Yeah, yeah.
So why it is? Why it is? It's because of this. Ice is less denser than water. Why? Ice is less denser than water, and it is
Water.
happening for this. mass you are taking same, huh? 1 kg water and 1 kg ice, and volume increases, then what will happen? Density decreases for ice. Do you understand what I'm saying?
Yes, sir.
Yeah, if you are taking ice of the same mass, you'll see the volume is more, that's why the density is less, and that's why ice is floating on water. And the same reason that when it happens also in our house, that also in your house you can test it. You just keep one uh, bottle of water uh, tightly, you fill the water completely in the bottle, fill the bottle completely, then close the cap and keep it inside the freezer. And when you see that the water freezes, and after freezing you'll see the water bottle will burst. It will be foreign. Have you ever
Oh,
seen
yes,
this?
sir. Sir, Coca-Cola can, sir. Coca-Cola
Yes,
can.
yes, yes, yes. This is happening. This is happening. You see, if the liquid turns to ice, then the volume expands, volume increases. That time, the because of the volume more, the container uh, broken. Sometimes it's broken, sometimes it's burst, or sometimes it's torn. Right?
Yes, sir.
You can have an experiment today. If you forgot or you don't understand it, you can test it at home. Okay,
স্যার একবার
everyone.
ডিপে স্যার একবার স্যার
Everyone.
আমার পুরো ফ্রিজ পরিষ্কার করতে হয়েছে স্যার, আর লাগবে না
Yes,
স্যার
yes,
পরিষ্কার করা।
yes. So you understand everyone this one, what I discussed. Aisha, Nubrat,
ইয়েস স্যার।
Rabi, Shafkat, Jawad, Faiza, are you
I got
understanding
disconnected.
what
Waste
we are
meeting.
discussing? Hello,
Hello, sir.
are you understanding what I discussed? Nubrat,
Say I got disconnected.
you got disconnected. No problem. You have the recording. Okay, you will get the recording. Follow it. Then what about others? Rabi, Faiza. Hello. Did you understand? Shafkat. Hello, Shafkat. If you respond, then I feel better. Hello, everyone.
Yes, sir.
Yes, you are understanding, but other students, their microphone is off. They are not responding. They should also participate, right? Okay, fine. You continue, huh? From here. So you understood this, huh? The process, huh? Why we are doing it. To prevent damage to the car cooling system, drivers add antifreeze to lower the freezing point of water. Okay, if it is not reaching to freezing point, then it will not turn to ice, then it will not burst. Is it clear, Sad?
Yes, sir.
Okay, now you continue here. In doing so,
Yes, sir. In doing so, even if the temperature goes below 0 degrees Celsius, water will not change to ice with the presence of the antifreeze as an impurity. Another useful impurity that lowers the freezing point of water is salt. Salt is put onto roads during winter to prevent the formation of ice, which will hinder traffic flow. Another useful application is to add salt to ice to give a freezing mixture that can cool something to below 0 degrees Celsius. Obviously, salt cannot be used in the car cooling system. Adding salt to car cooling system does solve the problem of freezing, but in so doing it creates another problem, corrosion, which is more serious.
So it's clear to you, right? That
Yes, sir.
adding impurities, we can change the freezing point or boiling point or melting point, right? All this we
Yes,
can
sir.
change. So similarly, we have effect of pressure on melting point. Okay, boiling point. We have effect of pressure. Clear to you?
Yes, sir.
Hello. Uh,
Hello,
yes, yes.
sir. Effect of pressure,
Yeah, effect of
like,
pressure
can you
on
give
the,
me an?
yeah, like if you are giving pressure on ice, you see, you read this part, then you'll understand.
Okay, sir.
Just
Effect of pressure on melting point of ice. Have
hmm,
you ever noticed that if you press two pipes,
two pieces.
two pieces of ice cubes together, they will stick to each other after you release them. Similarly, snowballs can be formed by squeezing lumps of snow together with the hands. These examples show that the melting point of ice is lower by an increase in pressure. When the ice cubes are or lumps of snow are pressed together, the parts of the ice or snow under high pressure melt. When the pressure is released, the water freezes and therefore joins the two ice cubes or lumps of snow together. Walking
So
on snow is difficult because of the effect of pressure, which lowers the melting point of ice. If the pressure exerted by the
food.
if the pressure exerted by,
Hmm.
yes sir, should I
Yeah,
continue?
continue. Yeah, continue.
If the pressure exerted by the foot is sufficient to melt the ice into water, the water refreezes again when the foot is raised. The ice formed on the sole of the boot as the foot is raised makes walking difficult. The lowering of the melting point of ice is due to pressure is often used to explain the mechanism of ice skating.
Yes, continue.
Sir, I didn't
Yes,
understand this line, sir. The
this
lowering
line.
of melting, yes, sir. The lowering of melting point of ice is due to,
Melting point is 0 degree Celsius, right?
yes,
Uh, but if it is given pressure, then it comes maybe -1 degree Celsius, right? -1 degree Celsius, the melting point. But you know that uh, what happens? Ice melts at 0 degree Celsius normally.
yeah.
But if you are lowering, that means the melting point becomes -1 degree Celsius. Okay, the
Oh,
surrounding area and the place where you are applying pressure, there is difference, right, in the melting point.
yes, sir.
So that's making a problem, right? And sometimes we are using it, to
In,
get some benefits also, right? So that one they are saying to explain the mechanism of ice skating. When the ice skater moves, her entire weight is supported by the thin blades of the skates. Since the area of contact of the thin blades with the ice is only a small fraction of the area of the blade, the pressure exerted will be high enough to melt the ice. Okay, the layer of water formed enables the skate to glide easily. So here we are getting the benefits, right? Ice skater,
Oh,
the sharp edge, there the ice melts due to the pressure. Okay, so if that is becoming water, then you can glide easily. But
yeah.
if it is water, then it's becoming slippery, right?
Yes, sir.
Then you can glide over there. Okay, then there is another theory that suggests that the layer of water is formed due to friction between the blades and the surface of the ice. Again, not only the pressure is working, also there is friction is working, right, in between blades and ice. And because of friction, there is heating, right? There
Yes, sir.
is heating, and because
Heating
of heating, there is also melting of
water.
ice. Yeah.
Yes.
So we are getting here also another effect. So both the combinations we are getting here. So it's clear, right? How
Yes, sir.
impurity and pressure is affecting the melting point, freezing point. And these things actually is not directly involved with your learning outcomes of CIE. If we go through the CIE learning outcomes, you will understand it. We are going there. Everyone's microphone is off altogether. Is there any problem going on? Net problem?
Yes, sir. I think.
Yesterday, I got the news that in some areas of Bangladesh, you know that they are maybe in the Chittagong area, Moeshkal area, that area. They are using
Yes,
the
sir.
dredger to take the sand from the river or from the sea. Do you know this dredging machine?
Yes, sir. Dredging machine.
So that dredging machine cut the submarine cable. Yeah, and because of this, yesterday there was interruption in network. You got some interruption yesterday, right? Network problem yesterday.
Very
Yes,
much.
sir. Network problem then, sir.
Yeah, and that was the reason.
But sir, my one is okay, sir.
Yeah, your part maybe there was no problem, but most of the part of the country there was network problems. So here, look, the learning outcomes we got here. There is nothing mentioned about the impurities or changing the boiling point due to the pressure. Okay, so these are the extra things. Okay, that's why some of the things which are extra we will skip from the book. Okay, but you, Sad. But as you are interested, that's why we discussed. Hello, Sad, and all. You understand what I'm saying? Hello, Sad.
Yes, sir. Hello.
You
Hello.
understood what I said from the learning outcomes.
Yes, sir.
We did not get
Yes, sir.
anything that
Some of
we
the
have to
things.
add the impurities or we need to change the pressure to change the boiling point. So these are the things extra in our book.
Yes, sir.
Those are not covering the CIS syllabus. So we will skip those things, right, from now on. Here
Yes,
too,
sir.
I just reminded you so that we can go faster. Huh? Look,
Yes, sir.
here we got boiling and condensation together. Huh? Can you read this part? Where is Aisha?
Yes, sir.
Aisha,
When
your microphone is working. Aisha,
Yes, sir.
yes, sir. Her
so
microphone.
you read. Aisha, you read. Saad is becoming tired. You should also
No, sir. I'm
participate.
okay.
Yeah. Aisha, you continue.
Boiling and condensation.
Yeah.
When a pure liquid on heating changes to a vapor at a fixed or constant temperature, we call this change of state boiling. This particular temperature is known as the boiling point of
Mhm.
the substance.
Okay.
Table 11.2 shows the boiling point of some
Okay.
substance.
Okay. So yesterday also we had this idea that what is called boiling is quite similar to melting, right? Only what is the difference in melting? We are getting liquid from solid. In boiling, we are getting vapor.
Yes.
We are getting vapor from liquid. Okay,
Yes.
that's the difference in the temperature. That's the difference in definition. And other things are same. On heating, we are getting here on heating. We are getting here constant temperature. Okay, other things are same. And another thing we got here, similar to melting point, we got here boiling point. So boiling point is the temperature at which any substance, a particular substance boils. That is called boiling point of that substance. So boiling point of different substance is different. We are getting here water. Water has the boiling point of 100 degrees Celsius. Alcohol, it has boiling point of 79. Ether, it has 35 degrees Celsius. Okay. Mercury, we have uh, 357 degrees Celsius. So it's clear to you, right? About the boiling and boiling point, all of you. Hello.
Yes, sir. It's clear, sir.
So
Yes,
now
sir.
condensation is the reverse process of boiling. Already I told you. Here we got also graph, and this one I was waiting for. You see, this graph is helping us to understand that it is at constant temperature. Look, boiling starts here and boiling finishes here. Here at point Y is still, it is still liquid, and at the point Z it's becoming vapor or steam. So for the entire process we need some time. There is taking of heat energy. There is taking of heat energy to increase the internal energy so that liquid can behave like steam. For that we need some time. Okay, during this time, during that process, the whole process, the temperature remains constant. So is it clear?
Yes, sir.
Everyone, you should respond, please. Shafkat, are you
Yes, sir.
there? Shafkat, is it clear? Aisha?
Yes, sir.
Yes, very good. So can you read this part, Aisha? The reverse of boiling is?
Yes, sir. The reverse of boiling is condensation.
Yes.
That is when the vapor of the same substance is cooled. It changes into a liquid at the same constant temperature as in the boiler.
Mhm.
Heat is given out during condensation to determine the boiling point, condensation point of the substance. We can continue heating the water in experiment 11.1 unit. It boils. As
Mhm.
a, a typical graph of temperature against time is shown in figure 11.11 as the heating curve of water.
Okay, very good. So we got already idea about boiling, and condensation is the reverse process. Yesterday we discussed that melting point and freezing point is same. But when we are saying melting point, we have to say melting point of solid, melting point of ice. We will not say melting point of water. Is it clear? Like
Yes, sir.
Yes, sir.
melting point of ice is 0 degrees Celsius. Again, freezing point. If you are going for freezing point of water, freezing point of water is 0 degrees Celsius. It's not freezing point of ice. Clear to you? When we say freezing point, we should mention the liquid. Freezing point of water is 0 degrees Celsius. Similar to that, boiling point of water and condensation point of vapor, water vapor, right? Is it clear?
Yes, sir.
Okay,
Yes,
so
sir.
I think melting, freezing, boiling, condensation, all these things you are done. And from this curve, you understood that how it is constant temperature during the boiling, right? And also,
Yes, sir.
if you see here, melting is also shown here. You see, ice. We gave ice at minus 10 degrees Celsius or minus 5 degrees Celsius. Uh, until it reaches to 0 degrees Celsius, it is ice, and it's taking some time for gaining heat from the surrounding area, and finally it's turning to water at X, and that time its temperature is also 0 degrees Celsius. And after turning to water, its temperature increases, and until the boiling point reaches. So it is clear, the graph is clear, the melting and boiling point during the melting process and boiling process, we have the constant temperature. Is it clear, everyone? Hello?
Yes, sir. It is clear, sir.
Okay, so we will get some questions related to it, both structure and the MCQ. That's why I'm asking you again and again. That time you have to understand it. Otherwise, if you don't understand, that time also it will be problem.
Yes, sir.
So here we have also some discussion effect of impurities of the boiling of water, pressure. We don't need actually this, okay? Boiling under reduced pressure. That's why we are skipping all this.
Yes, sir.
If you are interested, you just have a look, huh? Have a look on the book. Uh, then if there is anything you don't understand, you can ask me, no problem. I will answer, no problem. Now we have another thing, latent heat. Latent heat we will discuss in our next class. Okay, in our next class we will discuss latent heat and also specific latent heat both. Previously we had uh, heat capacity and specific heat capacity. You can remember, right?
Yes,
That
sir.
one. And similarly, here we have specific latent heat. So when we'll discuss, you'll get details. Now we are going to the learning outcomes again. We are going to the learning outcomes again. So how much is done? Can you check out? We are done
Yes,
till
sir.
here, right? Till E, we are done.
Yes, sir. State the meaning of melting point and boiling point.
So you already got the idea about boiling, and when we'll discuss the evaporation, then we'll understand the difference between boiling and evaporation, right?
Yes, sir.
And in the coming class, we are going to discuss latent heat and specific latent heat. Okay, and also we will discuss explain latent heat in terms of molecular behavior. We will also get this formula over there. So here we are going to have discussion of three things together. G, H, I. Together we will discuss. Okay, the next class. Okay, thank you so much. Huh? See you again in another class. When will be our another class? 110, right?
Yes, sir.
Yes, sir.
Okay. Thank you so much. Allah Hafiz, for the time being.
Allah.
Thank you, sir.
See you.